Okay, so this is an old example, I think, from our first week of class where we just had a basic product class. And these represent items in a store. And then I changed this a little bit. I added an array list of type product. I don't think we were talking about array lists at the time, not in our first week, but now we know what they are. So I have an array list of type product, and then I'm calling that products. And we have these gift shop items in that array list, okay? And then some column headers, and then I printed out the data in kind of like rows and columns, okay? Nice, neat format there. So what I'm doing in this application is I'm kind of farming out the basic tasks, the printing, and I actually did like an average price. That's another task. I'm putting those in Lambda expressions. Do I gain a lot in this program by doing that? No. But it serves to illustrate how we can construct a Lambda expression and execute it. Okay. So let's take a look. This one is a Lambda expression to print out the products like you see here. So this output here is being taken care of by this Lambda expression that I've added. Let me just show you. So this, without the Lambda expression, this was the old way that we would have done that. Just a simple for each, which is fine, okay? But let's do it with a Lambda expression just to get comfortable with that syntax. You know, a Lambda expression is really just, it's like a method with parameters and a body, and it does whatever you code it to do. So if you, and I know like the syntax is confusing, the concept is kind of confusing. It's difficult to wrap your mind around these because they're just so unlike anything we've done so far. But I just keep reminding myself, it's just a method. It's just a method that's packaged up and I can throw it around anywhere in the Java universe if I want. Okay, a method that is disembodied from any class and just, kind of a free agent, so to speak. So, we talked about you can't just have a Lambda expression, define a Lambda expression. You want to put it in a variable, and the type of this variable is a functional interface, okay? I am using one of the pre-existing functional interfaces that come with the Java class library. I'm using this one, consumer T, because what I'm going to do is just create some Lambda expressions that just kind of accept the whole, like a whole array of type product, and from there I can just loop through that array and maybe print out the things or get an average of the the prices or whatever. I just want to get an array in the door of the Lambda expression. So this is good because the parameter type is just one type. That'll be an array of type product for me. There's no return type or anything, just a simple functional interface to just get the array list into the Lambda expression, and from there I can do whatever I want with it, whatever I normally would do with it. Print out the products, get an average of the products, get a total of the entire inventory, whatever. Okay, so that's the consumer interface that I'm going to use. Look at the data type I provided. So in the angle brackets, you provide the data type. Okay, if I were dealing with integers, I would do like an integer with the wrapper class we talked about a while ago. But I'm not. I'm dealing with an array of type product, okay? Or an array list, I should say, of type product, okay? So that is the data type. I'm going to call it lambda print. I don't know if that's a great name, but just for instructional purposes, this is my functional interface object that is going to, contain that lambda expression for the printing. So I called it lambda print. Okay. Now we're at the point where it starts drawing parallels to our regular methods. Methods have parameters. Okay. I told you I just need one thing in the door here of this lambda expression. That is an array list of type product, and that's what's coming through the door. I named it very specifically. This is going to be the array list of products that ultimately gets passed into this expression here for processing. Okay, and then the usual syntax. One thing I didn't point out before in previous videos is this is weird syntax, having the semicolon after the body. So this is the opening curly, this is the closing curly, and then you have a semicolon after the closing of the body. So that's something that would be easy to forget. That's kind of unusual. We don't see that a lot. Okay, so now I'm home free. The array list is in the door, and I'm just going to loop through it like I normally would. This is the code that I would have used if the Lambda wasn't even in this program. So it's just back to the basics here. Okay, so I've got the code to print the products all wrapped up in a nice little package, a nice little Lambda expression. And now how do I execute it? Well, I'm just going to call upon my object, my functional interface object, Lambda print I called it. And this one, the method that you use to execute it is accept. And that's why I'm saying accept here. And then passing the product. Now, what is products? That's this. That's all the stuff. That's the actual array list of products in this program that we started with. So there is that. Let's just look at a second one here real quickly. Okay, so we have same type of thing, only this time I want to get an average. I want to get an average price of the products in this store. So once again, same functional interface. I'm going to go with that consumer guy, and I'm going to do the same type of parameter. All I want is to get that array list of populated with products in the door. Once it's there, I can loop through, I can get a running total, and then ultimately determine the average and even print the average. Okay, and that's what I'm doing. So once it's in the door, in the Lambda expression, I'm home free. I'm going to create you can create variables inside of here, whatever you need. I'm going to create a sum initialized to 0. I'm going to loop through the array list and tally up or total up the prices of each of those items in the array list. And then once the sum is in place, I can divide that by the size of the array list to get the average price. That's all. And I'm printing it. So I've got a lot going on in this one line. I'm doing the math and also printing it out at the same time. Okay, so that's in a nice little Lambda package, which I've called Lambda AVG. And then as with the printing one, I'm just going to execute that calling the accept method on that functional interface, passing the products array list, which is the original inventory for the store. Okay, just so whatever we've done, like all kind of the basic utility functions that we do, printing things, getting averages of things, you can package that in a Lambda expression. So just getting back to some of the convenience about using a Lambda expression, because like I said, we didn't gain a lot in this program by adding Lambda expressions. I mean, we learned something. We saw a demo of Lambda expressions, but let me do this. I do have something at the bottom. I'm going to comment this out, and then this is where I was actually executing the Lambda expressions. I'm going to do it a different way. Down here, you didn't see this, I didn't show this before, but I added a second method. So this is the end of the main method. I'm just in the main code file, right? Main program file. This is the end of that main file, or main method. I added a second method, a separate method, just to prove a point that I can pass a Lambda expression anywhere in the Java universe, and you're passing that code and executing the code outside of the file where that code resides. That's very unusual, and that's really why the Lambda expression is so versatile. It's why it's even a thing, okay? Is to be able to just, kind of pass these little pockets of code around and execute them from anywhere. Okay, so in any case, I have, I'm keeping the name really generic because I'm going to use this method to not only print the items, but also get the average. This is going to have a dual purpose. So I kept the name generic. It's just called process inventory. Who's coming through the door? A functional interface object, the consumer, okay? The consumer of type array list of type product. I'm calling it func interface, just to be very explicit what's coming through here. This is just a regular method, okay? And this parameter, functional interface, and then an array list of type product, which I'm calling products, which is actually the same name I'm using up here. No, I don't normally do that, but what the heck, I'll just leave it, okay? It is the same name. Okay. And then finally, once it's in the door, I just execute that accept method on the functional interface and, pass it the products array list, and then it's going to work. So I've got two calls here. Let me uncomment these. Two calls to that method. I just showed you the process inventory method. Who am I passing? Well, first I'll print out the items. I'm going to pass lambda print, that functional, the functional interface, the lambda print, that would print the products. Okay, passing the products array list as well. And then I will follow up by passing lambda average, which is the second lambda expression, the functional interface, wrapped up in the functional interface, and passing the products. So this will work just fine. Again, I'm like passing that code off to a different method, and it's being executed in a different method from which it resides.